morning, students. The topic is uni junction transistor, UJT. Okay, it's also called as a relaxation oscillator. Relaxation oscillator. Now, UJT, this is the diagram of UJT. So in this, it have two bases. One is base 2, another one is base 1. Then that's why this is called as double based. This is called as double base is there, no? So it is double based. Here, this is your p-type material, this is your n-type material. It form one junction, no? So p-n junction. Diode is, so this p junction is also called as diode. So this is also called as double based diode, because two bases is there, no? 1, 2. Then PN single junction is there, so it is called as double based diode. Okay, right. Then in this, n-type material is lightly doped. Then here p-type material is doped. The doping is heavily doped. This p-type material is doped one end of the n-type silicon bar. That end is closed to base 2. Okay, then so next this base 2 and base 1, no? Base 2, base 1. Then this is represented as PN diode. Represented as a PN diode. Here the arrow mark is in some angle, no? This angle arrow mark indicate the direction of the current. Direction of the current. Okay, right. This B2, okay, here is there. Then B1. So this is B1, right? Then here one resistor is present between, what is this? Base emitter and the base 1. So this is called as R resistor in base 1, no? So RB1. Then here another resistor is present between this and the base 2. So this resistor is called as, resistor is RB2, right? That's indicated as RB2 and RB1. The drop across RB1 is V1. RB1 is V1. What is V1? V1 is the drop across R1. This is, drop is eta V B B, right? Now this eta is nothing but eta is equal to intrinsic center ratio. This eta is equal to R B 1 by R B 1 plus R B 2. right? This RB1, RB2, now the total is called as total interbase resistance. T I R, total interbase resistance. Why it is called as interbase means the RB2 is lies between base and the emitter. Then here the RB1 is exists between the emitter and the base one. That's why it is called as interbase resistance. Okay, right. Any doubt in this? Right. Now, operation. Now listen. Initially, this B2 is connected to positive, B1 is connected to negative. The applied voltage is VBB, right? Okay. So this is positive, no? This is positive. That is, this B2 is connected to positive, B1 is connected to negative, right? Now listen, what happened initially here, the resistance is very low, no? That's why this holes are moved towards the base 2, that is minority carriers moving to base 2, right? Next, there is no holes are come from emitter to base 1 because the resistance is very high. Hence, small amount of initially there is no current movement, no current, but theoretically no current. Practically, it has some current. That is current is small current is flow from emitter to base 1. This current is called as leakage current. Very clear? That is before, listen here, before peak voltage. Before the peak voltage, there is no current, but this theoretically no current. Practically small amount of current is going, right? Then after that, that is the less than peak voltage. Now, here the voltage increases. Now what happened? Diode become reverse bias because anode is positive but cathode is more positive. Okay, so diode is reverse bias. Now what I do? I'm increasing the input current. I'm increasing the input voltage at a particular voltage. Are you clear? Increasing the input voltage. Okay, increasing the input voltage at a particular voltage. See here, at a particular voltage, that is, that voltage is called as VP, that is the peak voltage. Okay, once reach the peak voltage, input reach the peak voltage, automatically this voltage value is higher than this V1. Okay, that is VP. VP is greater than V1 plus diode drop VD. That is a small drop for silicon. It is zero point 0.7, germanium is zero point 0.3. Okay. Anyway, this VP is greater than V1. After what happened? Current, the diode is start conduction. Now the current is flow through the diode. Okay. Current is flow through the diode. You know the normal PN junction, what happened? Current is reached to zero point 0.7. There is, sorry, voltage reached before zero point 0.7. There is no current. After once zero point 0.7 reached there, the current will be increases. No, voltage is constant. The current will be increases. Here also same way. Here the input voltage. See here, this input voltage is very high. Which voltage? Hmm. This input voltage is this input voltage V is low, diode is reverse bias. Once at a particular uh, the input voltage increases to Vp. Now what happened? Diode become forward bias. This Vp value is greater than this V1 value. Diode become forward bias. Now the current is flow through the diode. So voltage is before voltage increases, there is no current. At peak voltage, what happened? Current will be increases. Current will be increases automatically. The voltage is decreases. Current will be increases automatically. The voltage will be decreases. Okay. So one quantity is current. X-axis is current. The current is increases. What happened? The voltage will be decreases. Okay, this region is called as negative resistance region. This is called as negative resistance region. Once negative resistance region. Okay, now this is called as valley voltage. This is called as valley current. Once the voltage is reach this valley point, after that diode UJT acts as a normal diode, then it go to saturation. It acts as a normal PN diode, right? Now see here. So before that, before Vp, before Vp there is no current, but theoretically no current, but practically small amount of current is there. No, that is called as leakage current. Then once it reach the value, input voltage, no, once the input voltage is reached the value peak point, then after that current will be increases. See here, x-axis is current. Current will be increases automatically. Current will be increases automatically. The voltage value, see here, here the voltage is Vp, no, Vp is very high. Here the voltage is very low. That is voltage decreases, current increases. Yes. Now listen here, same thing, same thing. Here the voltage is reached to the valley voltage. Voltage valley point. Valley point means minimum point. The voltage is reached the valley minimum value. At that time the current is, this is your IV valley current. Okay, voltage is reached the value. After that the UJT is cut off. Now it acts as a normal diode. Okay, so this is called as leakage current region. This is called as negative resistance region. This is called as saturation region. So three types of region is available in the UJT. Here there is no current theoretically, but practically small amount of current is flowing. Okay, that current is called as leakage current. After that, once the peak point is achieved, the diode become forward bias. In this region, diode is reverse bias. Okay, once peak point is coming, diode is forward bias. So current increases, voltages decreases. Then this region is called as negative resistance region. Okay, in this negative resistance region, it acts as a, that is UJT is act as a oscillator. UJT act as a oscillator, right? Oscillator na another. Oscillator is a device without input, it produces the output. Anyway, so in this region, negative resistance region, it acts as a oscillator. Yes, so for your clear understanding, see this. So this is your, what is this? This is your okay, so this is your cutoff region. There is no current. Then this is your saturation region, maximum current. Then in between negative resistance region, the current is, voltage is minimum, current is maximum. That's all. Okay, right. Yes. Now see here, UJT. UJT is a three terminal. Then only one PN junction. So UJT, lightly doped N region. Then heavily doped P region. This is allied where one side closer to B2. Okay, produce PN junction. Circuit symbol. What happened? Emitter leg. Emitter leg is drawn at an angle that indicate the arrow mark indicate the conventional current. Okay, right. Then characteristics. Characteristics. So listen here, interbase resistance, that is RB1 and RB2. Total interbase resistance is RBB. Then it have two bases, so it is called as double based diode. Next, voltage the RB1 voltage drop across RB1 is V1. V1 is equal to eta into VBB. What is eta? You know, eta is equal to RB1 by RB1 plus RB2, right? Okay. Then this voltage initially voltage and the eta value is 0.5 to 0.56 to 0.75. Voltage V1 is applied now. Then diode is in reverse bias. Okay, that the positive voltage applied to the emitter is V is applied once the value is the VE value is less than V1. VE value is less than V1. See here. So this is your VE value. This is your VE value. This VE value is less than V1. VE value is, see here, less than V1. What happened? Diode is in reverse bias. Once the VE value is equal to VP, maximum voltage, diode is in conduction. Anyway, these are the two things. One is VE value less than V1, diode is in cutoff. VE value equal to VP, saturation, right? See here, the VE value less than V1, cutoff, diode become reverse bias. Once the VE value exceed V1 equal to VP, right? Diode forward bias. That is forward bias. Under this condition, holes are injected. Now what happened? Holes injected more amount of emitter current. Holes, the value of holes will be increases. The moment of holes increases, automatically what happened? The resistance will be decreases. Okay. So this resistance is a, what is this? Variable resistance. During the reverse bias, this resistance is, that is VE value is less than V1. The condition, VE value is less than V1. What happened? See here. Okay. So this VE value is less than V1. This VE value is less than V1. What happened? Automatically diode is in reverse bias. VE value is greater than, what happened? More amount of holes are injected. Now resistance between emitter and base one is decreases, more amount of current flow. UJT is start conduction, right? These holes are next. This is B2, no? B2 is connected to positive. B2 is connected to positive. So this is positive. This holes also positive. Now what happened? Same poles repel each other. This positive and this positive are repel. The holes are repelled by the terminal B2. Repelled by the terminal B2 and attracted by B1 because this is positive, no? So this is connected to positive. Now what happened? This positive repel the hole. Now this is connected to negative. No. Now what happened? This is connected to negative. Now negative. Now what happened? Entire holes are attracted by the terminal B1. Okay, B1. Then now what happened? The reducance resistance is decreases. Then IE current is increased. Now what happened? It is the on state. Okay, if the negative voltage is applied to the emitter, PN junction remain reverse bias. Only positive is applied, PN junction is forward bias. Negative is applied, reverse bias. So the family of characteristics. This is the characteristics. Now what does this means? In this characteristics, what they told? The characteristics. This is your VE. Okay, so less than, it is the leakage, this what is that, less the left hand side is the cutoff region, right hand side is the saturation region, in between left and right, in between left and right, it is the, what is this, negative resistance region. So these are the characteristics of UJT. Anyway, you have any doubt in this, I'll explain in the class. Okay, it's not a problem, right? So please study. UJT relaxation oscillator, I'll take that in next video. Anyway, thanks for listening. Thanks for watching. So don't be lethargic. Kindly study. Thank you.